Hello everyone, this is Dr. Caleb Chen again, and today we are going to talk about the continuous probability distribution. And the example or the probability distributions that we'll be focusing on is normal probability distributions, which is a family of distributions defined by the fancy formula is 7.4 on your textbook. What we wanted to do is to simplify things a little bit and try to identify two parameters that define a normal probability distribution. They are the mean, mu, and also standard deviation. With these two parameters, we would be able to approximate the probability that's defined by, say, the two values. And you probably have heard of the notion that a bell-shaped curve, and we called a normal probability distribution a bell-shaped curve because of the way a normal probability distribution curve looks like. Pretty much it is a bell shape. So we have the mean here, and depending on the standard deviation, we would have something like this. It's bell shaped, and along the horizontal axis we have x, and then we have say the distribution. So if you still remember the empirical rule, which is also the 68, 60, 95, 68, 95, 99.7 rule, one standard deviation of the mean from here to there, it is approximately 68%. Where do we get that 68%? We'll figure it out. It has something to do with the normal probability distribution. So that would be mu minus 1 standard deviation, 1 sigma, and here's mu plus 1 sigma, and then 2 standard deviations. That would be the mu minus 2 sigma, and here is the mu plus 2 sigma, and that accounts for approximately 95%. And then when you go to 3 standard deviations, so mu minus 3 sigma and mu plus 3 sigma, that would account for 99.7%, almost 100%. And if we throw in some numbers here, we would be able to make more sense. If mu is equal to, say, let's say x is equal to IQ scores, with a mu of 100, the average IQ score of, say, an infinite number of people who have taken the IQ test has a mean of 100, and say sigma is equal to 10, then we are looking at, say, that 68% of the people would have an IQ score between, say, this would be 100 minus 10, or 90, and here is the 100 plus 10, that would be 110. So 68% of people would have an IQ score between 90 and 110, and then the 95% would have an IQ score between 80 and 120, and 99.7% of people would have an IQ score between 70 and 130. This is nice and easy because the empirical rule has this approximation, and so long as the distribution is bell-shaped, which has the center measured by mu, and also this is the same as median Q2, or we can use the mode 2. So all of these three statistics are identical, and we have a bell-shaped curve. We would be able to use the empirical rule. There are times that we are not going to just look at, say, what about 1, 2, or 3 standard deviations? Maybe we are asked to approximate, say, what's the probability or percentage of people with scores between say 80 and 110. Now, with our understanding of where the probabilities are, we might be able to estimate that, because say 80 and 120, they're respectively -2 standard deviation away and +1 standard deviation above. And we actually have just converted these two numbers into what we call the z-score. So we have a -2 and a +1, and if you go -2, that would be pretty much what the 95% divided by 2 according to the empirical rule. So that would be the 47.5, 0.475, and this being 100, which is the same as 0 standard deviation away, so 0, and this is 168 divided by 2, this part, 68% divided by 2, that would be 34%. So the answer to the question, say probability of say X IQ score is between 80 and 110, we can approximate that to be 0.475 plus 0.34. That would be equal to 0.7. Let's see the, okay, we have to add this together. So the 0.475 and 0.340, so it's 5, 1, and it's 8, so it's 0.815. So to answer the question, how often would you find people with an IQ score between 80 and 110, based on the meal and sigma that we have, and knowing that it's a bell-shaped curve, well, the answer should be about 81.5%. In the next episode, we're going to talk about, say, times when this is not an integer number, it's not an even number. For instance, well, it might turn out to be the 1.34, or maybe it is, say, the plus 2.59, and how do we approximate the probability without using calculus. So that would be our next episode.